Section 7.4 is now showing that triangles are similar by using the side-side-side similarity postulate or the side-angle-side similarity postulate. For the side-side-side similarity postulate, it says that if all pairs of corresponding sides of two triangles are proportional, then the two triangles are similar. And if it's side-angle-side similarity postulate, so if two sides of a triangle are proportional to two sides of a second triangle, then, and the included angles of both triangles are congruent, then the triangles are similar. I don't think that this blank should be here, so don't worry about that. So what basically needs to happen is you need to have two pairs of sides that are proportional, and then the angle between them congruent. Okay, so let's look at some examples. Example number 1 says determine whether the triangles are similar. If they are similar, write a similarity statement and find the scale factor of triangle B to triangle A. Okay, so we have two options in this section. We have side-side-side similarity, and we have side-angle-side similarity. It looks like we have three pairs of sides here, so we are testing side-side-side similarity, which means we want to make sure that all of the ratios are the same between the corresponding sides. So I'm going to say PQ, which is 8, corresponds to ST is 4, the 12 corresponds to the 6, and the 10 corresponds to the 5. If we reduce all of those, we do indeed get 2 to 1. So, are they similar? Yes. So, triangle PQR is similar to triangle STU by the side-side-side similarity postulate. This is your congruence statement. Now you want a scale factor K of triangle B to A. Now what we just did is we put A over B, but they specifically want B to A when they're listing the scale factor. So instead of 2 to 1, we have a scale factor of 1 to 2. Example 2, determine whether the triangles are similar. If they are similar, write a similarity statement. Okay, again, for this particular section, we have side-side-side similarity or side-angle-side similarity. Here, you could see that we have two pairs of sides and we have one angle, so we are going to test the side-angle-side similarity postulate. First, it's easiest to see that angle C is congruent to angle F, and those do correspond, and that angle is included between the two sides, so it's created by the two pairs of sides that we are given in the triangles. If there was any other angle in the triangle, it would not help us out. Okay, now we need to verify that the corresponding sides are proportional. So I'm going to say 3 over 5, because those two sides correspond, equals 6 over 10. I'm going to reduce 3 over 5 equals, reduce the 6 over 10 by 2, and we get 3 over 5. So those are proportional. Similarity statement would be something like triangle ACB, similar to triangle DFE. Your reason is by the side-angle-side similarity postulate. And if they wanted a scale factor, you could say the scale factor would be 3 to 5 if you were looking at ACB to DFE. You are now responsible for the checkpoint, and there are only 2 problems this evening.